Hello, this is Group 12. We are the automated dog door project. Firstly, I'm Mikey.
My name is Ang.
My name's Han.
I'm Dylan with the camera.
All right, so our kind of idea here was I know I have a dog myself, and whenever my dog has to go outside, you have to go down and open the door. It's kind of annoying, like when your dog wants to go constantly back and forth. So we were like, what if we were able to automate that process to just make it so the door opens itself? So we thought we'd make a prototype that would basically be able to serve that function using what we learned in mechatronics in the lecture and the lab portion, and just kind of combining that knowledge to see basically, yeah. And this is what we came up with for our project.
Switch. Alright, so for the circuit, we have a stepper motor that will activate when this key fob gets into contact with the RFID. What it'll do is open and close the door. And what we also have is a light sensor here. The idea behind the light sensor was to activate this indicator light so that when it gets dark out, say you live in a rural area where it gets really dark, the dog can still find the door. So the wiring for the stepper motor driver, and power supply is the same as from the stepper motor lab. The RFID wiring is pretty simple. For each of the pins, it needs its own GPIO pin, and then ground to ground, and the VCC power input pin goes to the 3.3 pin on the Pico. For the light sensor, same thing, ground to ground, power input to 3.3, and it also has a pin called D0. This pin outputs a 1 or a 0, whether it's dark or bright out. So you connect that to a GPIO pin on the Pico, and then you can read that output. For the LED, the anode side is connected to a GPIO pin so that we can control whether the LED turns on or off. And the cathode side goes to common ground. The 220 ohm resistor right here is in series with the anode side of the LED, and that's to limit the current so we don't burn out the LED. Yes, I believe that is it for the circuits.
And I'm gonna talk about the working principle of our project. So this is powered up by the speedo motor, and when the speedo motor gets the power, the crank is just gonna rotate where it gives the rotation, rotating direction, and where it gives the inputs link. This is the input link, this is the transmission link, and this is the output link, and this is the door. So when it gives the rotation movement to the input link, this is gonna pull back. The motor is gonna pull back, and then the transmission link is gonna pull back as well with the input link, and this is also gonna pull back. That way it's open the door, and there's gonna be 10-second delays. One is gonna close back, and it's just gonna open, and when your dog just came in, it's just gonna close back. Just think of it, this is a side view. So the dog is gonna come in this way, and this is the door. So there's gonna be a big door above it, and there's gonna be a small little dog door. So if the dog is gonna just kind of come here, RFID is gonna be right there. It's just attached, and it's just gonna open stuff. And that would be it. He's gonna explain about the coding.
For the program, it is designed to take inputs from the RFID sensor and the light sensor and output to the stepper motor. In the first part of the program, the GPIO pins for each component are set up accordingly based on the circuit layout. Two functions are defined for the stepper motor. The forward function will turn the motor shaft counterclockwise when viewed from the back of the motor, and the reverse function will turn the motor clockwise. As for the main part of the program, it first initializes and continuously monitors for an RFID tag swipe and reads ambient light levels from the light sensor. If a valid RFID card is detected, the system opens the door by rotating the stepper motor forward, waits for 3 seconds, and then closes the door by reversing the motor. An LED provides feedback based on the light sensor. It turns on when the surroundings are bright and off when dark. The loop includes a short delay of 0.1 seconds at the end to ensure stable operation and prevent overloading the pico bar.